7.1 or 7-1 is all about dilations. Make sure to pick up one of these little sheets of paper here that is in the notes and glue that in your notebook, as well as the foldable. You will fold along the dotted line. You will want to cut this line right here. All right, let's look at the properties first. So we're looking at the left-hand side first. The description of a dilation includes the scale factor and the center of the dilation. So here's an example. We use D for dilation, and my pen's not wanting to work. I feel like this is the beginning of every video ever. There we go. And then I would say about the origin, so O for origin, which is what we will use most of the time. And then whatever we want our scale factor to be. So an example would be something like 1/3. We want to take an image like a triangle, quadrilateral, polygon, anything you want, and cut it down in size by 1/3, but preserve what it looks like. Okay? If the scale factor is greater than 1, it is called an expansion. If it is a decimal or a fraction between 0 and 1, it's called a contraction. And so to dilate, we always multiply by the absolute value of the scale factor. Okay? When we do this, angle measures stay the same, parallel lines stay the same, collinear points stay the same, midpoints and orientations will stay the same. So they create similar figures, okay? So they might be different sizes, but otherwise they look the same. So let's go back up here and look at an example. I'm given the points -1, 0, 2, 2, and 3, 2. Oh, just kidding, 3, -2. So my first image looks something like this. I'll change the color. If I am dilating about the origin at a scale factor of 2, that means I am multiplying every one of these numbers by 2. So I'm going to get -2, 0. I'm going to get 4, 4. And I'm going to get 6, -4. Okay. So my new image looks something like this. Notice it looks the same as the smaller one, but just larger. So as far as proportions go, so think about it proportionally, it still looks the same. All right, one more example. This time we're going to dilate, so we're going to get smaller. So -2, 0, 2, 4, and then 4, -4. These are our original. All right, and this time we're going to dilate by 1/2. So that means multiply everything by 2. Multiply by 1/2, or, getting ahead of myself here, divide by 2. So I chose to divide by 2 because in my brain that's much easier. And that puts me right here. So notice this time, triangle still looks the same, but now it's smaller, okay? That's all there is to dilations. Dilations is not very difficult at all.